Hi everyone, it's time for another natural episode here. So today we will talk about the best labs ever. The best labs are the labs that you can spin up with a click of a button in a cloud instance so that you don't have to have a compute of your own and that you can run for free. This is definitely a fairy tale, but we kind of getting closer to it, and that's exactly what we will talk today about. Now, take a look at the screen. What you're looking at is an SR Linux stream and telemetry lab that we've published like 2 years ago, something like that. So this lab powers a data center in a box. So you have 3 leaves, two spines. You have a Grafana dashboard. You have a stream and telemetry collector next to it. And you see that the traffic is chugging. There's like a nice weather map that shows how the load balancing is working. And we also collect a bunch of stream telemetry statistics that display the routes and some environmental parameters of the switches and so on and so forth. So this is all cool. And although Containerlab is really easy to install, just like one command and you are off to the races, and even though the labs are really simple to start, again, it's just like one Containerlab deploy command and you are running, you still kind of have to think about the compute. Where do you run your lab? Where do I get these VMs that would power my Containerlab labs? And wouldn't it be nice to stop thinking about it and kind of have the one-click lab provisioning workflow that would A, get you a compute, B, provision the environment for you so that you can run your labs, and C, will be able to spin up the lab that you have defined as code in your Containerlab repository. This is exactly what we are going to talk today about, and this is powered by Codespaces and Containerlab. Let's go. How about we build this SR Linux streaming telemetry lab from scratch together with you, and you will see how easy it is to get started with labs now when we introduced Codespaces support. If you go to the SRL telemetry lab GitHub repository and you will scroll a bit down through the README, you will see this nice inviting button that says Run in Codespaces. So let's do that. Let's click on this lab, on this button. So when I click on the button and click on Create New Codespace, GitHub will create a development environment for me. And this dev environment is called Codespaces. Now you see that in the browser, I start to see a familiar VS Code interface that uses my styling that is connected to my GitHub account. But then what happens in the background is that GitHub is now building the Codespace. Now, before we jump into that, let this guy do its work, and we will talk about the Codespaces a little bit more closely. Well, Codespaces is just a development environment in the cloud created by GitHub, and it provides a very nice and smooth integration between your local VS Code experience and the development environment in the cloud. With Codespaces, you can get the same VS Code as you have locally on your machine, but it will run in the cloud. So you don't have to have a development machine where you run it. You can use the resources provided by GitHub. Now, if you think about the Containerlab and the lab as code promises that it provides, and then start to think about Codespaces, it kind of makes sense to combine the two, because now Containerlab labs are nothing but the code. So why can't we use Codespaces to spin up labs there? And that is exactly what we did. We created the documentation page on containerlab.dev website. So if you go to containerlab.dev user manual and click on labs and Codespaces, you will have a nice documentation around the integration between the two. So what we really did is that we just created a Codespaces environment or integration with Containerlab, so that when you create a Codespaces lab from a repository that hosts your Containerlab lab, then everything will come up naturally in a single click fashion, and you will be able to start your labs from the pre-provisioned environment. So let's go back to our VS Code that has been preparing by GitHub. So now you see that once I clicked on the button from the SR Linux telemetry lab repository, it opened up a VS Code UI for me. And I see my repository cloned. So I have my Containerlab file, the topology definition file for this lab. It all kind of happened automatically. I didn't have to do anything. So my lab or my repository is now cloned. I have a VS Code experience in the browser. I don't even have to have a VS Code installed locally. And then if I open up the terminal, if I click here and open up the regular terminal, you will see that I have the regular Z shell, and I can run my commands as if I would have run this lab on any Linux compute. So that is exactly what we are going to do now. So we use the same familiar sudo clab deploy command, and look what happens next. Containerlab is already pre-installed. You don't have to install it. Docker is already pre-installed. You don't have to install it as well. We made sure that the Codespaces integration with Containerlab has everything you need to run any lab, right? So what happens now when I typed sudo clab deploy, I started to pull the images, or Containerlab started to pull the images, because the environment that we have has no images whatsoever. So it started to pull the SR Linux container image because it's public, so it can pull it from the public GitHub container registry. It starts to pull Grafana, Promptail, GNMIC to boot up the streaming telemetry stack. But then once it will finish with pulling the images, it will start deploying the lab. And once again, this is all happens on a VM that I do not own, that has been provided by GitHub for me. We can actually check that. So if I use curl ipinfo.io, you will see that this is actually a Microsoft IP address that I'm using. So this VM is provided by the Microsoft, and I'm not using any compute of my own. It's all in the cloud. So going back here, we're still pulling the images, but what you can also see here is the size of my VM that I'm using. So let me make this bigger. So we are running on a 4 vCPU VM with 16 gigs of RAM. So this is one of the flavors that GitHub Codespaces provide for us. And we selected the 4 vCPU VM with 16 gigs of RAM for this particular lab. So every node in this lab, all the 5 SR Linux containers, the full streaming telemetry stack, and the full logging stack is running just fine in this environment provided by Codespaces. So going back here, we see that we are reaching to the finish line of the lab deployment. We started to run the post-deploy actions for all the containers. And in a moment, you will see that the lab will be fully provisioned and fully created so that we can interact with it as you would normally do. Now, before we start interfacing with the lab, I wanted to reiterate this. This is something that GitHub provides for us, and we started it with a single click. You will be able to do the same yourself if you have a GitHub account. Click on the button and you will have exactly the same experience. There is nothing that you would need to do differently from what I'm showing you here. So yeah, let's give it a couple of seconds, and then we will see that the Containerlab topology table, Containerlab table is present in the terminal, and we see all the clients, leaves, and spines being deployed. Of course, I can easily connect to any leaf that I have in my topology, so I can do show network instance, default protocols, BGP, neighbor, and we see that we have 4 neighbors, everything is established, and we are exchanging routes. That is sweet. But that's not all. You remember that we have the Grafana UI here, and all the telemetry stack things are visualized in the Grafana. So again, this is something that is nicely integrated with Codespaces. If you go to the ports table will list all the ports that we expose through the Docker API. So when we use the ports section here in the streaming telemetry lab definition file, like for Prometheus, port 9090 is exposed, for Grafana it's port 3000, all of these ports will be listed automatically here. And there is a forwarded address that you can use to open it up. So for example, if you want to open the Grafana, you just click here, and through the internet, through the tunnels to this Codespaces VM, you will be able to launch the Grafana UI as you would normally do if you would have to run this lab locally. And I can go to my dashboard, I can go to the streaming telemetry dashboard, and I will see exactly the same thing as I just showed you when we started to shoot this video. So you can interact with this lab exactly the same way as you would normally interact with it on any Linux compute. Again, this is just a cloud VM that is provided by the GitHub, but then it is integrated very nicely and deeply with the VS Code experience, and that makes it super easy for anyone to launch labs in the browser without having to have a VM. So if we go back to our terminal, we can of course start the traffic. So all the scripts that are part of this lab, we can do the same bash traffic sh start all to start all the traffic. And yes, you will see that the traffic is started to be fetched by Grafana by talking to Prometheus, and GNMIC collected the traffic counters using GNMI. So everything is super nice and smooth. Again, I wanted to reiterate that you can run the same lab yourself without even having a VM of your own. So if you want to run it in a cloud, if you want to run it like in an instant, you can use Codespaces and you will be able to do that. So while this is running, let's talk about money. Now, of course, you will not be able to launch and run labs indefinitely in Codespaces. Codespaces has a free tier, and the free tier is explained in our documentation here. So we have the free plan section here where we explain how Codespaces free tier works. With Codespaces free tier, you have 120 CPU hours a month and 15 gigabytes of RAM per month. What does it mean? Doesn't mean anything if you just like look at this table without reading much. So let me explain it to you. If you go to github.com/codespaces and I refresh this page to list my newly launched Codespace instance, it will say that I'm using a 4-core VM with 16 gigs of RAM, and we just saw that in the btop output. And this Codespace VM is active. Now this VM consumes 4 cores. And the free tier says that I can use 120 cores per month. This actually means that I can run this 4-core machine for 30 hours, because each hour I consume 4 vCPU cores, and in 30 hours I would exhaust my free tier quota, which is again 120 CPUs per month. Of course, pricing may change or the free tier terms might change, so always check the official documentation. This is how it is now. And if I go to github.com settings billing summary, you can see that I have the almost a real-time view of my usage. So currently I have consumed 16.15 CPU hours a month because I ran multiple VMs over time when I was preparing the Codespaces integration. But then you can also see that I'm way below my quota. That means that I run it for free still. I have more storage consumed, but that is again because I downloaded a bunch of stuff when I was preparing things. Your quota would be probably much lower. And the nice part about the free tier of Codespaces is that you will never be charged unless you explicitly raise your spending limit. So see here, 0 monthly spending limit is set for my account. That means that when I will exceed my quota, I will just not be able to launch any Codespaces VM, but GitHub will not charge me unless I add the billing information and I put some number here instead of $0. So that is really nice. That means that you can run the Codespace enabled labs as a user without even worrying that you might get charged. So this is something about the billing. This is quite cool. Now, what we also did is that we created a catalog of Codespaces enabled labs. It's not only a Linux streaming telemetry lab. It's actually any lab that you can think of can be integrated with Codespaces. And we have the catalog here, which you can look at if you click on this link. So it will show all the repositories that have been tagged with CLab Topo topic and the Codespaces topic. Now, if you want to enable your lab to be running in Codespaces, read the docs that are on Containerlab.dev and add these topics to your repo. Then it will automatically render here. And then your users will be able to spin it up and launch and have a very nice and simple user experience. So for example, if I want to launch this SO-Linux ACL lab, again, this is a button that I just copy pasted here, but what you can see here is that this machine is way smaller. It's not 4 CPUs and 16 gigs. It's 2 vCPUs and 8 gigs of RAM. So if I launch this guy, it will consume only 2 vCPUs instead of 4. And that means I can run this lab much longer, or I can run it many times throughout the month. And then after the month term ends, your quota will be reset to 0. So you can again continue using the lab until your quota is exceeded. So that is really a very powerful way to make sure that users can quickly spin up your labs, go through the examples or the workflow that you captured in your repository, and have the same experience as you would have if you would have run it locally. It can also be a very powerful tool to run workshops. If you would like to spin up a workshop and you have like 60 attendees, it's quite cumbersome to have 60 VMs provisioned to everyone. But everyone likely has a GitHub account, so they can spin up the lab with your repository that you prepared for the workshop and use their free quota to get through the workshop exercises. So this is really a very powerful way, and I would like to thank Piotr Ankudinov, who showed this approach to me, and that resulted in this integration between Codespaces and Containerlab. I hope you will have more labs integrated with Codespaces so everybody can easily test them out, see what you have built. And yes, happy labbing, and this has never been easier than this. See you next time.